If you want to graph a quadratic, often it's very easy to graph it from factored form. So if you don't have it in factored form, you're going to have to factor to get it there. But for our purposes, let's say we start with factored form. Okay? So I'm going to start with example 1, and then example 2 is a little bit more complicated. So factored form shows you the x-intercepts easily, and they are the numbers that are the opposite of the numbers in brackets, or the numbers that make the brackets 0. In this case, the x-intercepts then are positive 3 and negative 5. As coordinates, they're written as 3, 0, negative 5, 0, because they're on the x-axis. So they're along the bottom line here. So there's the 3, 0, and the 1, 2, 3, 4, negative 5, 0. Now if I had a 2 in front of the equation, or a negative 2, or anything like that, it would not make a difference. The x-intercepts would still be 3 and negative 5. Okay? Now, you might realize that there's a 1 in front, so this quadratic does face up, but we don't know exactly how far down it goes. And for that you need to find the vertex. Okay? Now we know that the vertex occurs halfway in between the x-intercepts, right? There's this axis of symmetry where the vertex is. And the x-intercepts will be on either side of that, equally spaced apart. So I know that my vertex then has an x value. It is negative 1 across. Okay, so it's left 1. And then I don't know how far down it is, but we need to calculate that. Okay, so to find this now, you plug negative 1 into your formula for every time you see an x. So you're going to plug it in twice because there's 2 x's in there. You don't plug in 2 different numbers, okay? So that used to be an x and now it's a negative 1. And then calculate this. So brackets are first, so I have to do negative 1 minus 3. Negative 1 plus 5 is 4, and I get negative 16. Okay, so my vertex then is negative 1, negative 16. So I'd have to go 2, 4, 6, 8, 10. It's further down here, but let's say it's right here. So I would graph like this. Make sure it's a nice smooth curve, arrows on either end. It's a little bit off, but you get the idea. Okay, so the steps are: first, find the x-intercepts. Then go halfway in between to find out how far across your vertex is. Then plug that number into your equation for both x's to calculate the y value, how far down, up or down it is. Okay, let's take a look at the next example. Now this one's a little different because we don't have a second bracket, we just have this x here. That means that one of our x-intercepts is 0. So the x-intercept here, a lot of people think that it's negative 2, but it's not. It's the number in the brackets. So this could be written as negative 2 x minus 0 x plus 4. So my x-intercepts are 0 and negative 4. And please do not write them with brackets around like this. That looks like 1 point. There are 2 points. Okay, so often what I like to do is not even write a comma, just write 0 and negative 4. Okay, so I have here and here are my x-intercepts. Then my vertex is halfway in between. So I know my vertex must be at negative 2, comma something. And this one's going to open down because of that negative number in front. So it's going to look something like this. And so we don't know how high up it goes, but we can calculate that. So to find out how high the vertex is, we plug negative 2 into our equation every time you see an x. Okay. So I plugged it in here and here. And now calculate. I'm going to do the brackets first. There's lots of 2's here. Negative 2 times negative 2 times negative 2 is a positive 8. So I get negative 2, 8 is my vertex. So 2, 4, 6, 8. There it is. And nice. Whoop, I missed that x-intercept. You get the idea. There you go. Hope that helps.